Okay, so this is a real brief presentation of the first 6 vocabulary words from Module 3 of your OLI textbook. That module is called The Big Picture. And this is the first topic, one of the first few things they talk about in that section on vocabulary. And you can read the definitions of these 6 words also in the workbook, Module 3, Topic 1. And in the textbook, they have some illustrations and pictures. So you can look it over there. And then the homework will ask you to identify the meaning of these words in some stories. So I'm going to start this brief slideshow. It's only like 4 slides this time. And I'm trying to break the course up into lots of little segments like this. Okay. So the first word to learn is 2 words, population and parameter. So a population is a big set of individuals to be studied as a group. And it's such a large set of individuals that getting data about each one individually would be too costly or too difficult to accomplish. So for example, we're thinking about maybe the set of all the citizens of the United States. That would be a population. And then a parameter is a measurable characteristic of the population. So like the average temperature of all US citizens. That would be a parameter of the population. So in order to find out the average temperature of all the US citizens, to really get it right, you would need access to all of the US citizens. But there are too many of them. You're not going to be able to go out and take everybody's temperature. They wouldn't let you if you tried. So that's a population parameter, something you would like to know about the whole population, but maybe the population is just too big to actually find out. Now about the notation, I'm pointing here at the letter mu with a subscript x. So if x was the temperature, this mu would stand for the mean or the average temperature. So that's a lowercase Greek letter. All right. And then the next item is about the sample statistics. So a sample is a subset of the population selected to represent the whole population. For example, a set of 100 randomly selected US citizens would be a sample of the population. About the use of the word, a lot of times students will say, well, we've got 100 samples. No, you've got one sample with 100 individuals in it. Now, what do I mean by to represent the whole population? I mean, what I'm hoping is that maybe I could get the average temperature of just these 100 individuals at the sample mean, and maybe that might be close to the true population mean. And what makes this mathematics is we'll talk about the probability that the sample mean is within some given distance away from the true population mean. So it becomes a probability problem to address the question, how close is it likely to be? So the sample mean is denoted by this symbol. I have an X with a bar or a macron on top, and that's, to pronounce that, you just say the sample mean of X. Sometimes I'll just say X bar. That's the sample mean of X, and it's intended as an estimate for the population mean of X. And the probability that it's close has a lot to do with how you get your sample. We want the sample to be representative of the population. What do I mean by representative? I mean that the sample is like the population. Ideally, if 12% of your population is left-handed, then 12% of your sample should be left-handed. And ideally, you should be able to do that for all characteristics. Of course, you can't list all the characteristics of a person, right? But you want to try to get it right even for the ones that you didn't even think of, the characteristics that would never occur to you to check. And what we'll learn something about random sampling. If you get a real random sample, as the sample becomes larger, the probability becomes higher that the sample will be representative of the population. The last two words are individual and variable. So an individual is just a member of the population being studied. So, for example, a randomly selected US citizen would be an individual in that population. The individuals don't have to be people. Population does not have to consist of people. Your population could be all the oak trees in a national forest. Each individual would be a tree. A variable is a measurable property of an individual. So if X was the temperature of a randomly selected US citizen, X is a variable. You might notice that the word variable here it's being used a little differently from the way you may have seen it in a high school algebra class. So in algebra, variable stands for an unknown number. They'll say something like, let X be the width of the book. You're given the area and the height of the book, so now find the width. This is different, a little bit. It's still a measurable property of an individual in the sense that, like if you were talking about the width of the book in an algebra problem, look at the width is something you could measure about the book, so that's true. But here in statistics, we're thinking about this variable as a function, where you give it an individual and it gives you back a value. So this capital X that I'm using here, and I'm calling it the temperature of a randomly selected US citizen, this capital X variable is really a function, and like X of Joe might be 98.6. So I'll use the capital letters for the function, and when I want to talk about just the value of the function for one particular individual, if I have the number, I'll write the number. If I don't have the number, I'll write a lowercase x. So the uppercase x is the function, and the lowercase x is the value of the function. And when we use the word random variable in statistics, we're talking about the capital X, the function. Okay, that's it. And so you want to go ahead and read through the discussion in the textbook and the workbook. And then there's some homework exercises that you'll find in Canvas. And when you're reading your textbook, I want to remind you a few times here at the beginning of the class, Now they have these check your understanding exercises. So as you read each page, they'll have a few questions and they give you feedback immediately. Those do not affect your grade at all, but it can really help you because it's easy sometimes to, to think you understand what they were saying because you do understand something, but might not really be the point they were trying to make. I mean, maybe they didn't make the point all that clearly. But answering those questions can let you know if you understood what they were saying in the way that they intended you to understand it. So I'd encourage you to take a look at those questions as you read. And that's all for this video. And I'll see you in the next video. We'll make many little short videos on each topic that we cover through the semester. Okay, see you next video.